Hello everyone, I hope you all are happy, healthy and fit. My name is Parth Patel and today we are going to discuss about a very interesting Python project which you can design and develop within a few hours. So let's start with the video. So basically this is what we can call as a Python mini project, and this project is ideal for students who want to demonstrate their Python skills in university as a university project or as a group project. Now, a special thanks to Professor Sachin Patel for mentoring this project in a very well manner, and let's jump right into the project details. So basically this project is about making a camera motion detector, and this motion detector is used for detecting any kind of motion that it captures, and then a graph will be plotted of that motion versus time parameters, and then this graph will have a log of entry time and an exit time of the object. So you will get an overall information about at which moment of time motion was detected, till which moment of time the motion was there, and when the motion exited from the frame. And also a .csv file will be generated from motion detector.py, and this .csv file will be used by plotting.py to create graphs. So now you may have noticed that there are two Python files that are in this project. One is motion detector.py and second is plotting.py. So basically motion detector.py is used to generate .csv file. So the main logic of detecting the motion is in motion detector.py, and with the help of the .csv file generated by motion detector.py, the plotting.py Python file will use, and it will create a graph, and that graph will be redirected to the default browser. Now, if you want to run this code, or if you want to run this project in VS Code or in any other IDE, then you need to run plotting.py if you want to get correct output. And also now some important details regarding the files. So basically there are two Python files as we have already discussed. One is for motion detection and other is for creating the graph. And in this motion detector.py file, there are four libraries that I have used. Number one is openCV, second is time, third is pandas, and fourth is DateTime. And for the convenience of the users who will be using this file for reference, if you are not able to get any line, then don't worry, because I have commented each and every line with some necessary information. So I have explained what this specific line means in the form of comment. So you can check out the comments and it's very easy to understand. So let's proceed further. So there are some import statements that I have mentioned in the import section. First is for importing the openCV library, that is from CV2, import CV2. Then we will be importing the time library, then pandas library, and importing the DateTime library. So all the four libraries that I have used, we need to first import that library. So here we have done the same process of importing the libraries. Now, first of all, we will be defining a variable called first frame, and we will be setting the value to none. Now, this variable will get the background or the first frame. I will be explaining the use of this variable in future. Then we will be having a list, and I have named this list status list. And here, for detecting the motion by changing the status code. So we know that there are two parameters I have here, and both I have set to none right now. Again, there is a list called times, and this list is used for sorting the entry and exit time. And then again, I am initializing the pandas library with data frame, and here I am, and this line particularly is used for creating data frame for .csv file. Again, openCV library object is created, and here we are using video capture function of openCV to start the camera 0. Now here camera 0 means the default camera or the inbuilt camera. If you have an external camera joined or plugged in with the laptop or PC, then you can adjust according to your priorities. It will make no difference in the code or in the logic, especially. Now the main logic starts from here. And now, first of all, the logic code is kept in while loop, and this is a very important part of this project because we will be constantly monitoring and we will constantly look for any kind of motion that has been detected till the time the camera is on. So for that, we need to process all the logic multiple times or in a continuous manner. So we will be using while loop, and that while loop will be set to true. Then we need to process the video till the user quits by pressing Q. So if you want to quit the video or if you want to turn off the camera, then you need to press Q from the keyboard. Now, the videos are stack of images changing at 30 or 60 or etc. frames per second. So if you are not getting this line, I will be explaining. Basically, videos are just groups of images that has been captured by camera. Now that image is transferred from the stack at a very fast rate. So we know that stack follows last in first out principle. So whenever the images are kept in stack, then we are removing that images, and that removal process is very fast, and it is such fast that for if we look that image removal process with our naked eye, then we will think that some continuous motion is going on. So this is the complete basic understanding about how videos work. And so basically we need to process the images only. We don't need to process the videos. So we will be processing each and every image. We will be stacking them up, and then we will be doing certain logical tasks so that the program can detect whether some kind of motion has occurred or not. Now here the while loop starts. So now the main logic starts. So this first line here, the main area is video.read. So now read is a function of openCV library, and it will start capturing the image. So the capturing process starts at video.read, and the images are stored in the form of numpy arrays. This is a very important point to consider. Here I have set the status as 0. This means that there is no motion detected in the camera till now. Now this variable stores the frame that has been captured in this line, and CVT color is again a function or a method of openCV that is used for converting the color image to grayscale image. Now, why we are converting the color image to grayscale image? The reason is very simple, that grayscale image provides better accuracy for motion detection. Again, we are using another function called Gaussian blur from openCV library again, and it is used for smoothing the image, and it removes the unnecessary noise from the image. So basically, it makes image a kind of smooth or very linear, in a linear form, so that any kind of noise or disturbance that is present in the image is removed, and it will enhance the accuracy of the image. Now here, this line is also again a very important one. So here we are checking a condition with the help of if statement, that we need background image for detecting the motion. So what does this mean is, we are here, the logic is as follows. We are taking a reference frame, and then we will be comparing each and every frame with that reference frame in order to check whether motion is detected or not. And that reference frame will be the first frame or the first image that is captured by the video camera. Okay. Now the first frame equal to gray, so this will assign a background image. Then the loop will continue. So here we know that normally first image is taken as background, that I have already explained. Here there is another function called .apsdiff. Now this is again a method or function from openCV, and it is used to get a difference. So as I said, that we are having a reference image, and again then we are capturing multiple images. So in order to know what is the difference between these two images, we are using this ABS drift function. Now the above function gives absolute difference between current image and the background image. And if difference is affirmative, then that means that motion was detected. Again, it's another function that we have used from openCV library, that is dot threshold function. Now this is used to return a tuple. Now the matter is straightforward. So why we are using this is explained in this two line. For every pixel, the same threshold value is applied. Now if the pixel value is smaller than the threshold, then it is set to 0. Otherwise, it is set to maximum value 1. Now you don't need to go into much more detail, but this will also is used for increasing the accuracy for the detection. Here we are using another method called the dilate method, and now it is used from the openCV library, and the areas of bright regions will grow in size, and hence the image size will increases. Again, this all the functions that I have mentioned right now till now, we are using it for enhancing the accuracy in order to make accurate decision. So we just can't, compare the two colorful images. We need to first convert it into grayscale image. Then again, certain processes are required so that that image becomes computer readable and computer can easily detect whether motion was formed or not. Okay. Again, now we are here finding contours. So find contours method is again we have used from openCV library. Now contours can be explained very simply that as a curve joining all the continuous points along the boundary. So as I mentioned already that if each and every line is explained and each and every method is explained in the comment section. So you can check it out. And if you find any kind of difficulty, then you can Google search Stack Overflow, etc. Now, contours are explained simply as a curve joining all the continuous points along the boundary, and we are having the same color or intensity. So here the threshold method was applied for getting better accuracy in the above function. It is similar to finding white object from the black background. So it is a reference example that I given comparing the threshold method. So now here we have used another method, that is dot contour area, and the contour area from openCV is used, and this provides the area covered by the contour. So now we are going into the smaller aspects of the object or image detection, and now here again we have changed the status to 1. Here we have used another method dot bounding rect contours. So it is again a method from openCV library, and it is used to draw an approximate rectangle around the binary image. So whatever the motion that will be detected, the boundary of the detection will be formed by red rectangle. Okay, here I have given the code for red color. Okay, and this function is used to highlight the region of interest after obtaining contours from image. So basically, when you will be judging out, then it will provide you an area, or it will provide an eye-catching attention so that the user can see that some motion is detected in this area. Okay. The rectangle method is again we have used from openCV, and it is used to draw a rectangle. So here you know that we have given the dimensions. Okay, so here we got dimensions from dot bounding rect method, and we are carry forwarding that dimensions to this rectangle method so that the rectangle can be formed at the exact location. Now this accuracy depends from frame to frame, so it might be possible that once the frame is removed, the shape of rectangle can change, or the size of rectangle can change. Then we are appending the status into the status list. So if you can see, then we have updated the status from 0 to 1, and we're appending that status into the status list. Now, here we are decreasing the list to last 2 elements as other elements are not needed. We need to compare just 2 frames, the reference frame and the current frame captured. So we will be reducing the size of the list. Okay, so in order to improve the memory. Here we had this statement is used for checking whether the status code has changed or not. If it has changed, then we will be appending the current date and time to the list. So here now we are using datetime.now. So dot now method will give the current date and time. Again, there is elif condition, and here we are checking whether status code has changed or not, and appending again the time. Okay, so we know that if status list is 1 and 0, and again we have to check for 0 and 1 because there are two possibilities, 1 0 or 0 1. Here some important methods, but this is not needed right now, so I have commented them. But if you really want to get into much more accuracy, then you can comment them, and it will be great to showcase your skills. Now cv2.imshow is another method that we have used from openCV, and this function creates a window, and this window will show you the image. And as I mentioned, the rectangle, this all will be displayed in this window. And remember, this window will be continuously be updated, and the images will be displayed continuously. So you don't need to do any kind of hassle. And here wait key is also another method, and here the wait key is used for deciding the time frame for displaying the window. So right now I have set 1 millisecond so that it will be convenient for judging all the frames. And once we have pressed the Q button, or once all the images are exhausted, it will be immediately closed. Here it is the condition for quitting the window. .ord accepts a string of length 1 as an argument, and it returns the Unicode point representation of the past argument. So it will give the Unicode of Q. And here if status is again 1, then we are appending the exit time when user terminates the camera. Okay, so here again, this is for testing, so it is not needed right now. But if you want to test on the terminal, then you cannot comment it, and you will get the time at which the user or the object motion exited. Okay. And this is all about motion detector.py. When here the video release is used for releasing the resource. So once we have utilized the resource, then it is necessary to release that resource, and for that we need to write these two lines. The video.release will release the camera, and with cv2.destroy window will destroy all the windows that we created. Okay, and these both are from openCV again. Here this is plotting.py, and here again I have used only a single library, that is bokeh. Now bokeh, whatever you want to pronounce, but it is a very essential library. Bokeh is a Python library for creating interactive visualizations for modern web browsers. It helps you build beautiful graphics ranging from simple plots to complex dashboards with streaming datasets. So now if you have got the idea, then we will be using this library for creating the graph of .csv file that we have generated from motion detector.py. Here we are again importing from motion detector, that is data frame df, and again we are from bokeh.plotting, we are importing certain elements. Okay, now here df. So for this two statements, we are adding a new column to the data frame imported. Okay, now this method called column data source is from bokeh.models, and a column data source can be considered as a mapping between column name and list of data, and a Python dictionary object with one or more string keys and list of numpy arrays are values that are passed to column sources constructor. Okay, so P here stands for representing the figure. Okay, and we have given a title motion graph. This is for height and width. We will be setting the y grid and y-axis. Okay, so now the above code will not show y-axis, and it is not required, as I've already mentioned. Okay, and we have used figure method from bokeh.plotting, and it is a subclass that simplifies the plot creation. Now, for hovering option, we will be again initializing the hover tool object, and it is again imported from bokeh.models, and it helps in enabling the hovering. Okay, we are adding it to the toolbar. Okay, again, this quad function is from bucket.plotting.figure, and is used to plot the quadrilateral in the graph. And now we are generating the output file, that is graph.html, and it will show the graph into the default browser. If a default browser is Chrome, it will open in that. If default browser is Safari, it will open in that. And this is for show POC. It will show the graph and it will display the figure. Now, one important thing to notice here is that if you really want this project to run seamlessly, then it is necessary that you should install openCV library, time library, pandas, DateTime library, and the bokeh library prior of running this program. And if you are not able to run this program, even after running this, even after installing the libraries, then you may update or you may reinstall the libraries, because this is a common problem. Or as you can watch for Stack Overflow for finding more commandable position. And if we want the source code of this project, then it is mentioned in my GitHub link. I have pasted my GitHub link and my GitHub account in the section below, and you can check out with that. And now I will be showing you the output